Take a second to read the question. Pay special note to this portion right here. The number of barrels of oil increased at a rate that is proportional at any time to the number of barrels they exported at that time. So when we think about what that really means, let's say B is barrels. The rate that the number of barrels is changing with respect to time is proportional to some constant of proportionality times the number of barrels they export at any time. Well, that's B. And so this, as we've talked about for a long time, can be separated into dB dt equals K dt. After integration, we will get the number of barrels is equal to the number of barrels that we initially have times E to a different R, some kind of rate of change, T. This might look more familiar as pert from a pre-calculus class. It also could be written as the amount of barrels equals how the rate that these are changing. So we're going to have still that initial number of barrels, B naught, times, if we were going to think about tripling every time, then we would have tripling times the time, or raised to the time, over, you might think of this as half-life or tripling time. This is the time to triple. Well, 3 would be tripling, 2 would be doubling. If we were talking about a half-life problem, this would now be a half. But whatever this rate is here can always be represented from information in the problem. So as we think about this, the company exported 5.6 barrels annually initially and 8.3 barrels 5 years later. What that would be in this case is 8.3 over the initial time of 5.6. That would give us a rate. And the time up here would be whatever time that we have over the time for that action to take place. So that would be over 5 in this case. So I'm about to show you how both of these equations give you the exact same answer, but how one of them gets there quite a bit easier. So in this case, our B naught would be 5.6 times 8.3 to the 5.6 over T raised to the T over 5. And in this case, we've got to figure out what this time is. Well, 2018 is 10 years after the initial time of 2010. So this is going to be year 8. That's what the number of barrels will be. After plugging all of these values into your calculator, you'll find that the barrels are 10.51, and of course, this is in millions. Okay, so that gives us the right answer. But let's take a look at what it would look like to do it using pert here, and that's our equation here. To use pert, or in our case BERT, for barrels, we've got an 8.3 million barrels. That's our final amount, and our initial amount was 5.6 billion barrels times E to some rate that we don't know about, but we do know that it took 5 years to accomplish this. So as we solve this, we'll divide by 5.6. After we divide, we get 1.482. Now I will take the natural log of everything, and in doing so, we'll have ln of that 8.3 over 5.6 equals ln of e to the 5r. Our log rules allow us to bring this exponent down, and of course ln of e is 1. So now we're looking at ln of that 1.482, which is a rounded number, equals 5r. We'll divide by 5, and our rate is equal to 0.079. This is also rounded. You could keep it on your calculator exactly. Now to get to this 10.5 million, we would have to go back to our original equation. Some final amount of barrels is equal to our initial amount of 5.6 million times e to this rate that we know, 0.079. And we also know the time. That time is also that 8 years from 2018 to 2010. So there's our 8 years. And now as we calculate this b, we're going to get that same 10.5 million. Do it on your calculator to make sure that you agree. I just double checked for myself. 10.51. So either way we get the same answer, but I hope you agree with me that the easiest way is actually to change pert into p equals the ratio of the final amount over the initial amount raised to some t over, it's not really half-life, but it is the time for this ratio to occur. So this will be time, and this is going to be our given time for this ratio to occur. Or, of course, one equation all the time, p equals p times e to the RT.